Hey everybody, Mrs. Zacher here, ready to talk to you a little bit about pH today. So pH is a measurement. It's something that we use in chemistry to figure out how acidic or basic a substance is. So pH is a really straightforward test that we can do for lots of different substances to see how strong or how concentrated they are or how weak they are. So pH stands for power of hydrogen. And so if there's a lot of hydrogen ions concentrated in a solution, then it has a stronger pH. And if there's less hydrogen ions, then it's weaker. So we can base this on a scale from 0 to 14, as you can see here. So 0 is where we have our acids, okay? So over here are our acids. I'm just going to kind of add on to this scale as we go through. And you can see that they're kind of colored as like red and orange and yellow. So again, the stronger the color, the stronger the acid, okay? And then on the other end of the scale, we have 14. Sometimes we call these alkalines, but we can also call them bases, okay? And bases we usually associate with like blues and purples, okay? So they're also quite strong or quite dark in color at this side of the scale. And then right in the middle, so 14 divided by 2, right, is what we would call neutral. So this would be at a pH of 7, okay? And so usually a pH of 7, this is usually what we're looking for both in water testing and within our own bodies in a lot of cases. So this is considered to be like a healthy pH, okay? Because it's balanced. It's balanced right between an acid and a base. Okay, especially when we're talking about water quality. Again, this is a quick test that we can do to see. So just to give you kind of an idea, as we go towards neutral, right, or as we go towards a 7, acids will get weaker. Okay, as we move closer towards a 7. And by the way, a pH of 7 is regular water, regular distilled water. Okay, so it doesn't have any kind of a concentration. It's not really strong. It's like a nice pure substance. Okay, so we actually have stronger acids on the far end. So if we had a really strong acid, we might measure it at a pH of 1 or 2, right? And as we move closer and closer to a pH of 7, they get weaker and weaker. So an acid that has a pH of 6 is actually really weak compared to an acid that has a pH of 1. Okay, and just to give you an idea, your stomach acid has a pH of 1, hydrochloric acid, which is a really strong one. Okay, the same is true for bases, but on the other side. So as bases move from 14 closer to a pH of 7, also they get weaker. Okay, and then as we look at the far end of the spectrum, right, this is where bases are the strongest. Okay, so sometimes we call acids corrosive. If you remember that from your Wimmis symbols, corrosive means to break down or kind of like burn away. Bases can also be very strong and break things down. Typical bases that we have with a really high pH are things like chemical cleaners. So things like drain cleaner and ammonias. So really strong cleaners that would break down chemicals or substances around your house, right? So again, strong on either ends of the scale. And as we move in towards the middle, it becomes neutral or healthy, right? Which is kind of where we want our water to be. Okay, so just to give you an idea of some other substances on the pH scale, I just Googled this picture and you can see again we have water sitting at a 7, so that's kind of the neutral substance that we're hoping for. And then you can see that for acids, acids are usually things that are like really, really sour. Okay, they might be sour in taste, like a lemon has a pH of 2.2. We talked about your stomach acid being really strong at a pH of 1. Battery acid is also very strong, which is why we recommend that you don't throw your batteries in the garbage, that you recycle them properly at like a London Drugs or a Staples. We can see too that vinegar and tomatoes, which also kind of have a bit of an acidic or a sour taste, sitting at about a pH of 3, tomatoes are about a 4.2. Except at about this pH here, fish will start to die. Okay, so if we're in an aquatic ecosystem or we're doing water quality testing in a pond, if we see a pH that's sitting at about a 4, that means we might have an environmental problem. We might have acid rain, or we might have some kind of a leak going on, maybe like extra fertilizer that's burning things away inside the pond. Okay. If we look at bases over here, a really strong base would be something like drain cleaner or bleach, okay, which we know can be very harmful. Even things like soap and ammonia, okay, are pretty strong bases. And as we kind of get closer, we can see that baking soda is a weaker base, and so is your blood. So these would be called alkalines or bases, and sometimes we can consider bases to be really bitter. So even things like celery are a bit of a base, okay? So in terms of water quality testing then, we can take samples, and you're going to be seeing this in my other water testing video, water quality testing. But here's a picture from the Vancouver Aquarium, one of the online chats that I went to go and visit in the wet lab. And she took a sample of one of their tanks because part of her job is to maintain a healthy pH in the water tanks so that those species are thriving and are healthy, and she can adjust things with different chemicals so that it's as close to natural as possible. So you can see here that she's got a little water sample. She can use different chemical indicators, so she can put little droplets in to test for things like pH. So depending on the color she gets in the tube, will tell her what the pH is. She can also test for things like ammonia or nitrites. So here she was testing for nitrites or nitrates. So again, a little bit of ammonia or a little bit of nitrogen isn't a bad thing in the environment, but if we have too much ammonia or too much nitrates, that might mean that we might have excess fertilizer or excess animal waste or excess sewage, and that's not good for the environment either. It can lead to things like algae blooms in water environments, which can end up being very toxic. So this was just a quick rundown for you of pH and the pH scale. I'll be giving you a little practice with this, and I hope that you enjoyed and look forward to my other water quality testing videos. See ya.